Good morning, Rob.
Good morning, Michelle.
Here we have the Theorem of Pythagoras task cards. Can you tell us a little bit
Yeah,
about how they
oh,
work?
absolutely. Again, a favorite material here. It is one of those materials. So the task cards themselves are, related to the material, and so this is most often found in upper elementary classrooms, in my experience. But certainly, in doing it and looking at the different frames, there are 3 different frames. They actually could do this in a 6 to 9 classroom. I never did it personally, but certainly you could revisit the Pythagoras theorem at different ages and use different insets for it. So first, Pythagoras theorem, it simply states that the sum of the squares of the sides of a right angled triangle will be equal to the square of the hypotenuse. Interestingly enough, in The Wizard of Oz, that's what the scarecrow, to show that he has a brain, that's what he recites in that. So that's basically what the theorem states. What the materials do themselves is it takes the child through a sensorial proof, so actually proving it by moving the pieces around. Then it shows it arithmetically, because there's an arithmetic proof to it. 3 squared plus 4 squared equals 5 squared. So if we had a right angled triangle that had a side that was 3 and 4, the hypotenuse would be 5, and that's how we would prove it. And then there's a third frame called the geometry proof. The geometric proof, sometimes called the Euclidean proof, because Euclid was the philosopher, the Greek philosopher and mathematician that came up with that proof. But basically still proving the same thing, that the squares of the side is equal to the square of the hypotenuse. So again, those are the materials. With some of these task cards, again, we revisit the idea that one, it's a task card, it's a command card, so it's not meant to replace the presentation that the teacher or the parent has given. It's meant to supplement it. It's meant to give the child work and structure to do after they've done the presentation. The Pythagoras theorem, again, with the 3 different insets, you see them pictured here with the sensorial proof. Once you've shown it to the child, what does the child do with it? And certainly they can repeat the presentation, but for a 9 to 12-year-old, not so much interest in repeating it. So this gives them more tasks, and lots of tasks to do. So you've got there are 12 cards here that are telling you, show that the blue and yellow squares in the sensorial proof are congruent. That means taking both of them, putting them together. So things that were points that were part of your presentation, but perhaps the child, like, it washed over them because they were paying attention maybe to the overall. So this sort of takes it more step by step. The second one, this is going to reflect the arithmetic proof, and the arithmetic proof is going to show it again. So what is the square of 3? What is the square of 4? How does that relate to the square of the hypotenuse? And so they have a series of cards for that. And then finally, the geometry proof, the geometric proof, not really intuitive. It's not something that you would be able to look at and go like, oh yeah, I know how to do that. So it's step by step by step. And so just as the teacher is going to go through that lesson step by step by step, it's a fairly long, engaged one. This allows the child to be able to do it on their own, because it's also giving them okay, this is what I do, this is what I do, this is how it's proving it. I think after this, and certainly having a nice stack of yellow cardstock, red cardstock, and blue cardstock, so the child can also construct that on their own. It's also a nice independent work that the child could do along with those task cards.
Okay, thank you so much for the explanation.